Hello, and welcome to another installation of Garage Astronomy. I'm your host, Damon Pewitt. Today we'll be discussing gravity and curvature. And to do any good experiment, you want to start with a question. Today's question will be, why do we fall back to Earth? Our hypothesis for this question that we will test? Aliens. Well, we can't really test aliens, but we will prove that it's not, basically. Now, Einstein, who made, as we all know, E equals mc squared, stated that matter curves the space around it. Now, the curvature from that matter is from the gravity, which is from the mass of that object. Anything that has mass and takes up space has gravity and is considered matter. Now, the gravity is what affects the curvature of the space-time, curvature of the fabric of space-time around the object. And the distance from the center of the object determines its curvature, and how much curvature it has. Now, does size matter in the universe? We'll see. Why do things orbit others? Well, if the curvature of one object isn't exactly enough to bring in the other object, which it is here, then the object will continuously fight each other with their gravitational forces of continuing to orbit around each other. Now, would the gravity and the curvature make objects faster or slower, further or closer to the distance of the center of the object? And what do we mean by wobble? And of two objects close or further apart in variations, would they fall at the same rate in the same curvature? Now, Earth, even though it is larger than Mars, has a closer orbit to the sun. Mars is further away. Mars being smaller, Earth being larger, size doesn't matter here because the orbits are different, meaning the curvature affects them differently. Earth being closer, moving faster, even though larger, with only a 365-day year. Mars, being almost that plus half, is 687, and further away, moving slower and smaller, but less affected. And we can show that here. We'll do Earth and Mars, centered around their sun. Earth larger, but still closer to the sun, would fall first, making it the shorter orbit. Now, even though two objects of different sizes can have different curvatures and different masses, causing different effects of gravity, this obviously larger object has less curvature because it has less mass. And the escape velocity would be less of these objects to get out of the orbit. Now, it doesn't take much to get away from this one, but getting trapped in this orbit because the more of the curvature is a lot harder, causing it to crash. Now, even on Earth, two objects, even though one heavier than the other, if they were falling from the same distance in the same atmosphere, same gravity, which is the gravity of the Earth, and them being small enough to be affected, would essentially fall at the same time because of the gravity on Earth and the curvature affected at the same time. Now, with the wobble, what we mean by wobble is the movement of distant stars and their own respective curvature of their own curvature caused by their own gravity would still be affected by another star with enough gravity and curvature in its orbit, causing it to wobble. And this wobble of these stars, even though we can't see them yet, can pretty much predict where a distant planet should be around that star, causing it to wobble. That's how we find exoplanets today. So, to go back, does size matter? Not necessarily. How much gravity and curvature an object has depended on its mass and the distance from the center of the object. Why do we fall back to Earth? Gravity and the curvature from its gravity, not aliens. E equals mc squared was right. Einstein was just in saying matter curves the space around it. Earth does in fact have a longer year than Mars, even though it's bigger. The sun, being bigger than both, has the biggest effect of the curvature on the two, causing them to be stuck in orbits. But even though Mars is the smallest, it is furthest away, causing the slowest orbit. And since sheer gravity and size of the Earth compared to something in its atmosphere would cause all objects thus to fall at the same rate. Not aliens, Einstein. Thank you, and I hope you have a good week.